the UAE leadership of enforcing the role of innovation and knowledge economy in developing the economy of this country and creating new opportunities for private sector, public sectors, and entrepreneurs. It's a reflection of the UAE leadership of enforcing the role of 2020-30 for the United Arab Emirates. We are delighted and lucky in Sharjah to have the ruler of Sharjah, His Highness Sheikh Dr. Sultan bin Mohammed Al-Qasimi, as the chairman of the Sharjah Research and Technology Park. His Highness' commitment to education is massive. He invests not only monetary resources in developing the infrastructure of Sharjah when it comes to innovation and education, but his dedication is immense to developing the whole ecosystem of education and knowledge economy in Sharjah. We at the Sharjah Research and Technology Park focus on four main objectives. The first objective is to develop an innovation ecosystem, not only based on the infrastructure of building and the street, but also the mindset of people. We also aim at developing next generation scientists, entrepreneurs, and leaders that can support our drive toward innovation. Our third objective is to focus on catalyzing knowledge economy, investing in technology and science and entrepreneurs so that we can have an impact and create enterprises that support the economy of the country and the economy of Sharjah and make it more competitive. And last, our fourth objective is really to invest in the future. We at the Sharjah Research and Technology Park, we identify companies and we vet them and we invest in these companies and we scale them up. Our objective is to create enterprises that will create economic, sustainable business. We at the Sharjah Research and Technology Park focus on 6 main subjects. The first one is water technology. The second one, production design and architecture. A third one is mobility, logistics, and smart cities. Fourth one is healthcare and digitization. And fifth one is renewable energy. And last but not least, environmental technology and circular economy. These are the 6 areas we focus on. And these are the 6 areas that we believe our colleges, our private sector have a competitive edge to grow and develop. We believe in triple helix. We work with government, private sector, academia, and non-for-profit organization to develop our ecosystem of innovation. We have launched research activities with universities, and we're trying to commercialize this research. We also engage with government and implementing best practices when it comes to artificial intelligence, blockchains. We launch sandbox with ministries, and we work with businesses as well in developing and commercializing technologies that will make them more sustained and more competitive going forward. We pride ourselves at the Sharjah Research and Technology Park to be able to attract some of the leading technologies into our park, whether we're talking about 3D construction or additive manufacturing or agriculture technologies or photovoltaic R&D centers or transport and mobility technologies or mixed realities. We pride ourselves to be part of a 47,000 students ecosystem at 22 universities and education institutions and more than 2,000 PhD holders, all in the same place within the vicinity of the technology park. Since its inception, Sharjah Research and Technology Park managed to attract global players, regional players, and local players. We pride ourselves to work with international companies like GE, like Intel, and Nokia, for example. We work with GE on additive manufacturing. We work with Intel on solutions related to educations and reskilling. And we work with Nokia, for example, on IoT labs and other things. We also have regional companies leading in additive manufacturing like Amensa. We have also mobile fueling companies like Kafu, and also we have companies in health like Nipta. We also have local startups that are thriving and really defining the way forward. Since an inception at SRTIP, we believed to have a global vision and regional mission. We believe in partnership, sustainable partnership. That's why we work with countries, with academic institutions, with science institutions, and with UN-led organizations as well. The objective is to develop sustainable partnership and a win-win situation for everyone. We developed the Sharjah Research and Technology Park based on best practices. And its start, we managed to benchmark Sharjah against 9 other cities around the world, from Boston to Marseille to Shenzhen to Bangalore to Hyderabad to Philadelphia. We looked at 6 main innovation criteria, like market and investment, inter-firm activity, knowledge and R&D, human skills, infrastructure. And we looked at these things and we benchmarked with other nations around us to see where Sharjah is vis-a-vis this nation and learn from these activities as we go on. Here are some examples of the bright technologies that we are developing here in Sharjah. We pride ourselves to have the largest or one of the largest transport and logistics innovation center in the world. We in Sharjah developing next generation technologies that will be promoted in this region and will become an integral part of the mobility solution in the Middle East. We also pride ourselves to have significant investment and technology development in hydroponics and aquaponics and agriculture technologies. We believe that the Middle East food security insists that we develop these type of technologies, and we work hand in hand with the private sectors, with entrepreneurs, and with academias to develop these technologies here. Third, we also developing a photovoltaic R&D center. Our main is to promote renewable diversity and bring new source of sustainable diversity to the energy mix when it comes here in the park. We pride ourselves to launch Energy Innovation Hub, a regional platform to engage and attract innovations into this region and link them to the industries of energy within the region. We also pride ourselves at the Sharjah Research and Technology Park to host one of the largest makerspace in the UAE, the Sharjah Open Innovation Lab. This lab dedicated to entrepreneurs, to faculties, to companies to come and co-create and co-innovate the future of technologies at the park. We develop and promote this soil lab by engaging with different players, whether you are an investor or a company or academia. They all come and co-create and create businesses and enterprise out of this lab, which features cutting-edge technologies in textile technologies, electronics, metal, 3D technologies, and others. For SRTIP, collaboration with academia is an integral part of our work. We work with universities in the UAE and around the world. For example, the American University of Sharjah is one of our key partners, and we work with them on three main areas. One around IP and commercialization, entrepreneurship and development of science, employment and internship, and also lab exchange. We believe to have innovation, we have to develop human capital and develop a strong link to academia and academic institutions. Here, I would like to share with you some other examples of the innovation we have here. We've managed at SRTIP in collaboration with academia and industry to create a fantastic footprint, a regional lab for construction of 3D materials. So we have today printed many houses using 3D technologies and using collaboration with education as well. Another example of what we do is we develop IP, intellectual property, and commercialization of the IP, and the topic, for example, here is conductive concrete. Another example of R&D is we are developing an exoskeleton technology that can apply for healthcare sector and also apply for industry within construction as well. And we do this in collaboration with academia and in collaboration with the private sector as well. The Sharjah Research and Technology Park also thrives on developing an ecosystem. I have spoken about the Middle East Energy Innovation Hub. This is a platform to develop new innovation within the energy sector. To be able to conduct our work at SRTIP, we have developed a comprehensive ecosystem that includes events and themes like the Women in Technology, promoting circular economy, and launching various accelerators. Our flagship accelerator is the Sharjah Advanced Industry Accelerator. We pride ourselves to be a home for the Middle East North Africa Innovation Technology Transfer Summit. We would like to position Sharjah as a platform for technology innovation and technology transfer in the whole Middle East. And we work with scientists, with science institutions, academia, private sector to be able to do this. In addition to that, we run a series of events at the Sharjah Research and Technology Park. These comprise webinars, exhibition, conferences that allow businesses and partners and tenants of SRTIP to engage and grow and develop their businesses and build up strong network with investors, businesses, academia, and government. We also launched the Sharjah Angel Investor. The main aim of this angel investor is to create funds and make funds available for startups to come and grow out of Sharjah. We also host many delegations, international delegations, throughout the year at the Sharjah Research and Technology Park. We host a lot of webinars, and we aim to do more of these webinars to cement relationship with countries, with industries, and with different players. Sharjah Research and Technology Park also have fantastic facilities for exhibition. We host many exhibitions and conferences at the park, and we aim to continue doing that going forward. This is a summary of the Sharjah Research and Technology Park. I hope you enjoyed the presentation. We look forward to working with you. We will look forward to partner with you and grow with you. Thank you.
So that was a short presentation by the CEO of the Sharjah Research, Technology and Innovation Park, His Excellency Hussein Al Mahmoudi. So in today's webinar, we have brought together companies from the heart of the 3D concrete printing industry and some of the most passionate names in this space. We will first go through a short presentation journey where our guests will do a better job than me in introducing themselves and their companies. And then we will have a roundtable discussion where we shall hear their thoughts on different aspects of 3D concrete printing regarding its effects, drivers, challenges, and commercialization. So first up, the first presentation will be by Henrik Lund Nielsen, the CEO and co-founder of Cobod International, whose gantry printer has probably reached every part of every continent. Henrik, take it away.
Thank you very much. I'll share my screen. Start with. Can you see? Ida, can you confirm that you're seeing?
Yes.
You're muted. Okay.
Yes.
Hello, everyone. I am Henrik Lund Nielsen. I'm the general manager and founder of Cobod International. Without the usual Danish modesty, I dare to say that we are globally the leading provider of 3D construction printers. We were founded some 4 years ago, but we have now already grown to 70 employees. We're very international. We have around 50% of our workforce is international, and we have sold more than 3 printers on 6 different continents. We're only missing Australia and New Zealand. The first printer was sold in 2019, so these 30 printers have been realized within the last years. And as I said, we've gone through tremendous growth and are seeing tremendous growth. We doubled in 20 and tripled here in 21. Part of our success is created because we have a partnership with our German shareholder, XtreeE Group, which is a globally leading formwork equipment supplier. So you can say the supplier of the manual competitive solution to casting concrete on site, formwork equipment. And obviously that was a big boost to us to get XtreeE in as a shareholder, because it was basically saying that the conventional industry thought so much of the potential of our industry that they decided to join instead of fight us. And what we do is we develop, manufacture, and sell gantry printers for on-site printing of entire buildings. And we actually do it in global cooperation with world-class companies like GE, General Electric, with XtreeE, Larsen & Toubro in India, JDC in Japan, locally here, Emaar, and also Dar Al Khan in Saudi Arabia. So quite some big names, but we also have, you know, the smaller startup as customers. And then in addition to that, we also do quite a lot of research in 3D construction printing, together with universities and some of the leading material suppliers, CEMEX, Holcim, etc. Now here you see a map of, I hope it is updated, where our printers are located. I cannot guarantee it completely because it goes so fast. It also shows another thing, which is that we are on the way with actually local offices, regional offices, to be closer to our customers. So we are creating regional offices in the US, in Dubai, and in Kuala Lumpur here during 22. And that is to service our global customer base, consisting of construction companies, windmill manufacturers, precast plants, EPCs, engineering, procurement, contracting companies, real estate developers, and R&D institutions. Our track record is pretty unique, so we have a lot of world's first, including Europe's first 1-story, 2-story, and 3-story building. The first buildings in Africa, the first 2-story building in India, the first 3D printed windmill tower, etc., etc. So you can see we are very broad and large scale, and that is the focus of our company. Here is a view of our printer. In the length, we can go as long as you like. In the width, we usually recommend to limit it to 12 meters. We can go to 15, and in the height, we go to 10 meters, but because of the height of the printhead itself, the printable height is around 8 meters. So that's enough for 3-story buildings. I know that Romain and some of the other robotic arm guys will say yes, but it takes forever to move and set up and take down. But that's in fact not the case. When you have done it the first time and you know how to do it, you can actually do it in less than a day. Both things to set it up and take it down again. And if you have in mind that you are building buildings up to several hundred square meters, we don't think that this is an issue with a few hours of setup and take down time. There are 8 reasons why this is the best-selling printer in the world. One of them is that it was the world's first 2nd generation. That means this is not a prototype. This is actually after we did prototypes, and after we had done one printer, we decided to do an even better one. And this printer has been tried, tested, and verified on 6 continents since early 2019. So it's a very safe and tested product that has gone through all the child diseases and so on. It's open source. That means you can put mortar to it, or you can put real concrete to it if you like. That's up to you. We don't dictate people what materials to print with. It's a modular printer, so it consists of modules of 2.5 meters. So we can build it to the size that you need. You're not forced to have a certain size. We have this unprecedented print speed of up to 1 meter per second. To put things into perspective, if we printed a 50 square meter building with 1 meter per second, we would be done in 2 hours. I think that says something about the speed. And then obviously it comes with all certifications, CE, IP66. That means it's safe for outdoor usage. It doesn't mean that you should use it in rain, because that's never clever with concrete, but you can, and it's not going to be dangerous. And depending on whether you choose a mortar or concrete version, you need either 2 or 3 operators. We also have this flexibility when it comes to how the wall design is, because you can change basically the width of the wall from 3 to 30 centimeters, and you can change the height from 2 to 5 or even more. And then we have this unique feature of having flaps combined with tangential control, which will provide you with a very smooth finish if that's what you're after. I have to say, a little bit to our surprise, most customers for their first projects actually choose not to use the flaps because they want people to really see that it's 3D printed. So they rather go for this little bit of belly printing or sausage printing, where you can see the lines pretty clearly. Here's the first 2-story building done in Europe. It was actually done by building students. So it was students that printed this building, which shows that even if this is very advanced technology, it's not more than advanced than that we can actually teach students how to do it. This is the first project from Perry, our partner. If you notice, it's 160 square meters on 2 floors, quite uniquely designed. It won a design award also. It was print time was 38 days. Remember, this is the first project. Anytime you do something for the first time, you'll never be perfect at it. But notice what happened to the speed. The ground floor took 28 days, but the top floor only took 8 days after they got the hang of it and understood how the printer is working. And that kind of productivity continued then when Perry did their really large project, the apartment block here, where there are 5 apartments in, and it's 380 square meters on 3 floors. And you see there each floor were printed in 7 days, so 130 square meters per day, in 7 days. And these are the kind of productivity increases that our customers are seeing. Most extreme example of that is our own building. So when we did the Europe's first building back in 2017, made a lot of mistake. It was the first time. It took 2 months. 2 years later, and with a better printer, it took 28 hours, an exact copy of the same building. So we went from 2 months to 28 hours. If we had to do it again, we would probably be down to 10 hours or something like that. So there is this constant productivity gains that we are realizing, our customers are realizing, which will prove that this technology is very competitive and economical. And by that, I end my presentation.
Thank you very much, Henrik, for this very interesting presentation. Now let's hear from Romain Dobelay, who is the co-founder at XtreeE, who has contributed greatly to 3D concrete printing, both through his research as well as commercialization efforts at XtreeE. Romain, over to you.
Yes, in an instant. I'm sharing my screen. Hi, everyone. Thank you for inviting us here. So, can you see my presentation? Yes. So I'm one of the founders of the company called XtreeE, which is one of the pioneering companies of large-scale 3D printing. And we are complementary as what Henrik just showed, because we don't do on-site printing of living units, but we focus on what we call off-site prefabrication. So we work as well with a lot of different partners, public and private. Vinci and Holcim are minority shareholders of our company. And we are trying to build an innovation ecosystem around the world and around large-scale off-site 3D printing. So this is not the same technology as we just saw. It's based on more little layers, and it's mostly done to do, let's say, complex geometries for whatever use you can have. The printing itself is a principle that we replicate to all the material that we develop, and it's called bi-component system, meaning that we mix the pumpable material automatically, and then we transform it into a printed head so that we can deposit layers of material and they can gain structuration at early age. This system and this nozzle can be moved by any robotic system, robotic arm or gantry, but we mostly use robotic arms for their 6-axis freedom of trajectories. It's quite rapid. Sorry, it's quite quick. This 2 meters column makes 30 minutes to print. So we can get pretty fast prefabrication element with complex geometry. This complex geometry is at the service of easing the construction site ecosystem in general. It's also at the service of performance when we try to develop new products with better environmental impact, better thermal properties, better acoustics properties, and also a very high freedom of geometry for architectural creativity. We develop a lot of different material. We work with all the big cement providers. We develop earth, plaster for indoor use, and geopolymer. And globally, we're trying to develop low carbon material in general. We have various ways of making structures of different scales, depending on the context where we use it. So sometimes we can use a printing context as it is, for example, in masonry, or we can use it as a formwork, or we can use it in a post-tension fashion, for example. So all depending on the context and on the scale and on the relevance of what we are fabricating. So just a few pictures of project to illustrate. So this is, of course, a very, very complex piece of architecture that is quite quick and quite cheap to make if you use a 3D printer. This is a 12-meter pillar that we've done 3 years ago, and it's intended to be used in a seismic area to act as a telecommunication tower and to be able to accept vegetalization over it. This is an example of different underground works that we have done and that are pretty interesting economically, because you can have prefabrication even when you need a custom geometry. Another example of easing the construction site when we fabricate little pieces that raise often a lot of problem even in standard buildings, and we can bring them to the exact geometry on the site. We are working on this project right now. It's due to 2024 for the Paris Olympics, and it's a 45-meter long bridge that will be entirely in printed concrete in a post-tensioning strategy. We have conducted a little environmental impact study on this bridge to see whether or not it was relevant when we compare it to traditional and kind of innovative post-tensioned concrete-based bridges. And in general, we tend to examine what we have as an economical and environmental relevance of what we're doing. And we can see that our solution, which is solution A on this diagram, brings quite a tremendous impact reduction compared to the two other solutions, which is interesting to us. We have recently been into housing as well. And we have had a permit in France to do this prefab house. So all of this is not printed on site, is completely prefab so that the construction site is more controlled with less delay. And basically we are prefabricating multifunctional walls. That's the principle of it. Biodiversity projects that we do a lot for regenerative design. We are called by many companies that want to benefit from complex geometry to play with biodiversity and species. Furniture design, and I will end with it. This is another example, and this is a table that you can have worldwide and that you can customize on the website of Roche-Beaubois that we have developed with them. So at the end, our activities are between an engineering office where we try to design relevant products, and we are selling as well our machines to partners while trying to make a relevant business case with them. So today, the first private machine that we sold was actually in Dubai to Concreative, and we have now a machine in Japan, 2 in the US, 1 in China, and 2 in France. And we are in the process of telling others, but of course I cannot tell. And we are trying to build a network of innovation for 3D printing. To finish, that's what it looked like when we installed it on a robotic arm. And this is the end of the presentation. I thank you for listening to me. And I hope to have the discussion with you after. Thanks.
Thank you, Amma. It was a very interesting presentation. I was trying to fall asleep. You didn't let me. Next up, let's hear from Yannick, the CEO and co-founder of Roop. Yannick has been involved with not less than 5 3D concrete printing projects, 3 in Germany, 1 in Austria, and another 1 in the US. Yannick, can you tell us more about yourself and Roop, please?
Yes, sure. Just share the screen. Can everybody see it?
Yes.
Perfect. So my name is Yannick Masierski. I'm the CEO of Roop Gebäudedruck. Gebäudedruck is the German word for house printing. For big house printing, so not the small houses. And we are focusing as a general contractor, not for selling machinery. We want to use machinery. So what we are not a technology provider. We are a construction company who is using additive manufacturing for the construction industry. So a small thing about the Roop Group. So everything starts with Michael Roop Bauunternehmung. Bauunternehmung means also in German, so sorry for everything, but it's a German-based company, and our focus markets is Germany, Switzerland, and Austria. So Bauunternehmung means construction company is the German word for it. And this one was founded in 1996 by the father of the two brothers, which I will show you later. And everything started with a masonry company. He started with 2 employees, and yeah, they are still there and make turnkey ready real estate. They make reconstruction, so everything standard in construction. So they make multi-story houses, they make single-story houses, they make bungalows, they make multi-family houses, and so on, but everything based on the traditional construction. Then in 2017, the oldest son started to be part of the company. And in the same year, he started a real estate company. So in 2017, they had 2 companies. One is construction company, focused on construction company. The other one is focusing on developing real estates, buying land, developing the real estate for the land, and selling the property or rent the property. And then since this year, 2021, I became part of the company, of the Roop Group, of the family company, as one of the founders for the Roop Gebäudedruck GmbH. And there also the younger brother Sebastian became part of the company as well. So we 3 are the founders of it. At the left side, Fabian Rupp. He's from his profession, a master in masonry and steel concrete formwork, so he's a craftsman. And then me, I'm from professional construction engineer. I was a former lead R&D and application engineer at the Perry AG, and I was actually the project lead of the multi-story house what Henrik showed you in his presentation. And on the right side, we have Sebastian Rupp. He's a banker from profession, and yeah, he's focusing on the financial part in our company. We are at the very beginning, so our company is now 1.5 months old, so very, very young. And we started to create a new headquarter in Bavaria, in Germany, and we will finish it next year. There we will have several office buildings, halls, and stuff to be able to create a business in the 3D printing field, because I mean, it's not only you buy a printer and then you can start a 3D printing business. When you want to make or to become a turnkey ready general contractor, you also have to you need story place, you need place for your employees, you have diggers, you have bigger machineries, so everything. And this is our step to the future, that we have all 3 companies in one place. And yeah, we want to make our or grow our business from there, and bring it into the world, but first only to Germany, Switzerland, and Austria. In 2020, the Roop Group, at this time, the normal construction company, started a project together with the Perry AG. And since that, the Roop Gebäudedruck was a brand of the Roop Group. It wasn't an own company. And the own company is now built since the 1.5 months, what I told you. And we started to print the building. It's actually the biggest 3D printed building in Europe right now. And we start printing or assembling the printer in October 2020. Started with the print at the 21st October and finished it in December, in the middle of the winter at -2 degrees. So it was kind of a challenge. last year, or no, this year I printed in Arizona at a heat of 35, 40 degrees. So I have everything done right now. And yeah, so we finished the whole building, the turnkey ready building in July 2021. So that is what I meant. I mean, you have the printer, but to plaster, you have to that took us in total 8 months. You can see from October to July, it's 10 months, but 2 months were winter break. Then here also, if you're a friend of plastering, you can make it the 3D printed sausage structure. You can just make it smooth with plastering. You can use flaps, what you were also able to see in the presentation of Henrik. Yeah, so you can have every standard what you can already get from the conventional construction industry. And if you want to, you can just make it, yeah, make the building looks like every normal building, or you can just show the 3D printed facade or whatnot. So there's no limit. I'm done with my presentation. I hope it was quick enough. I have had 5 minutes. So yeah, I'm open for questions, everything now. Thank you very much.
Thank you very much, Yannick, for your presentation. We were supposed to have Enrico Dini, the CEO and founder of D-Shape, with us today. D-Shape printing, by the way, for those that haven't heard of it, is probably one of the oldest 3D concrete printing technologies that came about. I think he will probably join us. He's probably a little bit late. He messaged a while back. He said he could be a little bit late. So we'll catch up with him later. Let us start. I would like to start the discussion now, if you guys don't mind. And basically, there are certain drivers that are driving 3D concrete printing in the market. And they're expecting certain effects of 3D concrete printing. The most important of these effects is that of sustainability. We know that right now, one of the mega trends in construction is decarbonization and reaching the net zero carbon point. And we also know that the industry accounts for 36% of the global energy use, 39% of the CO2 emissions. Buildings by themselves account for 40% of the global energy use. So my question, and I'll pitch that first to Henrik, and then I'll go around. Do you think that 3D concrete printing is actually delivering solutions in terms of decarbonization? And I know, Henrik, that I think in one of your projects, you used recycled tiles, if I believe. Tell us more about that as well.
That's correct. I come 10 years from the recycling industry, so obviously I wanted to use recycling materials. So we put 23% recycled ceiling tiles or roofing tiles into the concrete recipe. If I should answer your question, I think the most correct answer will be that there is a lot of potential for lowering the CO2 footprint of concrete constructions. There's a couple of requirements before that happen. One is that we start printing with real concrete, and we have developed such a solution so that we stop printing with the mortars, because the mortars, everything else being equal, contains much more cement, and cement is what is damaging when we talk about the CO2 footprint. So we have to go to concrete which are similar to the normal concrete, and then we should take advantage of that. Our technology has the ability to place material exactly where we need them. We don't need everything to be solid and so on, and therefore we can optimize the structures, even topology optimize them. That means take away parts of the structure which is not giving any effect in terms of being able to withstand forces and loads and so on. There has been some initial work done on that, but a lot more work needs to happen on that. But the first thing that should happen is that we should all be starting printing with real concrete, not with mortars. And we have done that process, or our customers have done that process here the last year. But we definitely should start seeing that on a larger scale.
Yeah, but Henrik, you're comparing, mortar to concrete. But really, I mean, what I'm thinking is, how do we compare it to traditional construction? I mean, traditional construction, we're using block work. What we're actually replacing is block work.
Well,
right? Masonry.
That very much depends on where you are in the world. It also, in terms of the CO2 footprint, Holcim's daughter company, or Lafarge Holcim's daughter company, 14 Trees in Africa, they printed the first buildings in Malawi. They actually issued a CO2 study, a carbon footprint study in that connection, saying that printing with, and that was a mortar, printing with a mortar there was actually more economic, more environmentally friendly than the traditional blocks that were being made there. You have to look at the entire lifetime also, because if you use weaker materials like blocks, etc., the lifetime of the buildings are not so long. But if you print with if you make buildings with concrete, they last forever, more or less, so to say, right? And you have to take also the lifetime into effect. And I also have to say that certain times the building regulations are not helping us, because it's making us taking some unnecessary steps to be compliant with, let's say, the technology and the solutions of the past, because that's how the regulations were written. They were written to comply with the solutions and technology of the past, and therefore they are not foreseeing the new possibilities that we are offering. So before we really see the full potential, we would also have to see all these building regulations being adapted to construction printing, and that obviously will take some years before that happens.
Are you suggesting, Henrik, that you would like the building regulation to increase the lifespan of the buildings?
No, I'm suggesting that the building regulations should allow for other methods, so to say, than the methods that have been the conventional methods so far, right? And should be more flexible, etc. And obviously there is work happening also in the RILEM. There's work going on trying to standardize printing materials and so on. But because buildings are so long lasting, this is also a long lasting process to get building regulations changed.
Yeah, I mean, like from my perspective, I mean, we have had buildings using blockworks, and blockworks, they're either made of clay or very weak concrete. That's mostly, there's very low carbon footprint, and that's lasted 50 years, and that's worked. My next question, Romain, if you don't mind, you are using a different type of mortar, and you're using sort of prefabrication. Do you think that prefabrication has any benefits to add in terms of decarbonization or sustainability compared to on-site printing?
Well, I think the environmental impact, we have three ways to act on it: the materials, the geometry, and the building process. So of course, I think we all agree that we are, and I think we are all trying to print and develop new materials that have lower impact in general. I think the complex geometry, as I showed the example of the bridge, is more easy in prefab. So it's also why we choose that, and this geometry can be at the service of optimization, lightweight structure, and overall reduction of the impact. Of the environmental impact. We should mention as well that to print, we are using energy, and we are using machines that themselves have an impact. And this is something that we embed thanks to a PhD that has been finished in Paris recently. This is something that we know how to embed in our printed material. And this is interesting because this goes as well to a conclusion that we found, at least for, let's say, bridge type or big scale structure, is that sometimes it could make more sense to use a very performant and quite impactful material, but very long lasting and of a very good quality, that you try to make, to put as few as you can. It makes sense in terms of impact reduction, maybe more than printing, a lot of low impact material that you will spend a lot of energy on printing. So I would say that every case is different. And as Henrik was saying, this is not the end of it, and we are in the process of the studies with the academia. So we need to understand better what we're doing, but it's definitely the main objective, at least for us.
If I may, we're printing with concrete here. Do you think that concrete is more durable than normal masonry? Do you think it will last longer?
It depends. It depends on the building system, and it depends on the material. But usually, yes.
In general.
In general,
usually yes.
we are printing mostly high performance concrete, which is almost non-porous, and it's one of the champions of durability. You can put it underwater and it doesn't move, right? So it's of course far more durable than blockwork traditional.
And in your design process, Roma, because I think you mentioned that you do a lot of design as well in your studio of the items. Do you push for a longer lifetime for your printed elements, or how does the lifestyle? Is there an effect with the authorities? Are they willing to reason with you with that, or is it as per normal construction?
Yeah, in my opinion, we should push for a longer lifetime. I think it does not apply maybe to every part of a building, but at least the structural parts of a building should have a longer lifetime. And maybe we can play with the other part of indoor envelope and make them in a different timeline. This is something that is extremely difficult with the authorities today, but I think we are all part of different regulation committees in Europe and in the US and abroad. And basically, yeah, all the regulation authorities are taking, slowly the go into it. But as every new technology, we need to wait, 10, 20 years before having like a full done code. For now, we can only have, project permits and progressively bring the authority to move. That's how it works every time. And we are all in the process of doing it.
Roma, you mentioned that, we can, with 3D concrete printing, one of the advantages, we put material exactly where we need it. Do you think that is actually saving material compared to masonry? Again, we're talking about buildings here.
Well, I think it is absolutely true for big things like the bridge, as I mentioned the study. For masonry, in my PhD, I have developed a system to do truss-like printed elements that is still not used industrially right now, and this makes very, very lightweight walls to be used in masonry. So it makes a tremendous reduction of weight, which has, I think, got a lot of good indirect impact on the building in general. But we made, during the PhD I mentioned before, a study on this building process to compare it in terms of environmental impact to masonry. And we found that even if we do such a great weight reduction, in terms of environmental impact, we are comparable to, let's say, the best innovative blockworks that include already insulation today. So I would say that even this, that is such a lightweight geometry, a space truss, is not a tremendous reduction of impact. It's a reduction of impact, but we have also compared it in the, sorry. We have also compared it to a reinforced concrete wall for high-story building with a hypothesis of reinforcement of the space truss. And here, in this context only, but it's interesting because it's the same object compared in a different context. Here, it's extremely interesting, and it makes a huge reduction of impact. So it depends on the object and on the context of yours and on the comparison, of course.
Yeah, just before I get to you, Henrik, just give me a minute. I just want to put things in perspective to our viewers. Why am I talking about saving material? I mean, I've got statistics here that tell me 34.7% of Europe's waste is from construction. If we can cut on that, that is massive. And just before I get to you, Henrik, just give me a minute. I just want to go to Yannick real quick. I just want to ask Yannick, you have worked on 5 projects, and everybody's saying there is savings in materials. Have you witnessed those savings in materials?
So it depends on the structure, and it depends also on the country. Right
on
now,
your projects, Yannick, on the projects you have worked on.
Yeah, right now we have the same amount of material, but that depends. That the reason for that is permissions. So the code standard in Germany, because right now we are not allowed to use 3D printed structure. We are not allowed to put the structural loads on it. So we right now in the process with the authorities in Germany to prove that the structural parts are also can also be done by 3D printing. I don't know how it's, for example, in the UAE or in other countries, but in Germany it's very difficult to get those permissions done. And but we are very confident that we have done that in the next 2 years, that we can only say, hey, we can put the whole load on the 3D printed parts. And then we have a significantly reducing of building material. Right now, we have a mix of 3D printed parts and also casted concrete parts. But it's just, it's insane right now because we are not allowed to use a mortar or also a print material which is able to load higher loads than the normal concrete. So that's the status today. But
you shouldn't change the stiffness of the building. Henrik, you wanted to say something?
No, but that's exactly the point that I made initially, that although our concrete and even the mortars that are also being used on our machines are stronger than traditional conventional concrete, we are not allowed to use it for load-bearing construction in general. And I'll give you another very illustrative example of how difficult it is to be sustainable in real life. I know everybody's talking about it, but few are really realizing how difficult it will be. You talked about waste. Yes, 40% of all waste in Europe is made out of construction waste. And what is one of the biggest fractions in construction waste? Yes, that is concrete, or even brick for that matter. That would work wonderfully as an aggregate in our concrete. Why don't we use the old building waste to create even concrete, to create new concrete with? I tell you why, because most building regulations in Europe will not allow that you make concrete out of recycled materials, period. You're not allowed to do it. So I mean, the regulations are really limiting the creativity. The creativity is there from the businesses, but the building code are regulating us out of those possibilities.
Yeah, and when you
can I ask if you're saying you're not allowed to use recycled concrete in the 3D printed material. I know that is the case for structural concrete, but what if you convince the authorities that this is not structural concrete?
That's exactly, those are the kind of games that we then do. So then we print walls that are bloody strong. We don't say that they're structural, we say they are facade elements. And then we print columns, and then we cast them out with a bloody traditional, conventional, 100% virgin material, because everybody's happy then. And it's very unsustainable because we used more material than what we had to. That's what I mean. The building regulations are blocking the sustainability aspect and sustainability potential because we are forced to do both things.
Okay.
I mean, we have to prove that everything is safe. I mean, for example, in Germany, when you want to have a building material approved, it needs years, and we are right now in that process, and that is okay. That is good. Because we have to deliver safety for everybody. And in my opinion, we are on a very, very good way. And topology optimization should come later on. I mean, that's our goal. As Henrik already said at the beginning, The goal is to bring more sustainable buildings into the market. That is a goal. We are not there yet, but the potential in this technology itself is so high that we are working in that field. So, for example, the Bot 2 printer, you can use it with mortar, you can use it with concrete, you can use it with geopolymers, you can use it with natural material. It's just a machine. The material what you fill in there, it's up to you, and it's also up to the land where you are, and so on and so on. It's a complex system. So the question what you ask us at the beginning has not one answer. It depends on so much effects and parts. It's not easy to answer.
Thank you, Yannick. I just want to welcome, I think Enrico Dini has joined us in the webinar. Thank you very much for being with us, Enrico. I'm sorry we missed, I think you missed the presentation session, but can you just briefly, in a couple of minutes, introduce to us verbally about D-Shape and yourself and your work with 3D concrete printing? Just a few minutes, please, Enrico.
Yes, you hear me, first of all.
Loud and clear, loud and clear.
So, love to see you all. My name is Enrico Dini. I'm the inventor of the shape particle bed 3D printing process. I live in Italy. I have a friend in Denmark that is Henrik Lundsen, my homonymous. Used to be my follower, but now is my surpasser abundantly. and glad to share and to join the conversation. I am just out. I had to leave a meeting for an important project in Saudi Arabia. You may have heard about the NEOM project. So I had to say goodbye and to join with you. But it's a sincere pleasure to be here and glad to share about the challenges and possibilities of my process. Please go on.
Enrico, you just tell us also a little bit about the D-Shape, you know, when did it start and what is it? Just a few minutes on that.
D-Shape is used to be called monolith, but the beginning was, the project was even called Mastercam in 2004. Then I called it monolith in 2005. Then a friend of mine involved in marketing, 3D in marketing, said, Enrico, you won't go anywhere with monolith. Allow me to suggest you a new name for your technology. That is D-Shape. So this is how the story began. I was young. I was around my 40s. Now around my 60s. So I spent a life in trying to inspire the world and spread inspiration, transpiration, perspiration about digital manufacturing. I created a market. I can proudly say that I created this market from zero. Now I might say that most of the application are focused on extrusion because it's easier to apply, is safer to apply, it's much less, let's say, it's much less complex, despite it's complex itself, because it's not easy to pour layers of mortar on top of each other, because you need to have a precise robotic system, a very well rheology property of the concrete, a very good business model, and surely Henrik has, because he's the most successful applier of the so-called contour crafting. The inventor, Barry Kokosnelis, despite he's a brilliant inventor, didn't have the talent to apply this on a global scale. So it's not easy to make a good coffee. About D-Shape is it's a raster printing system, digital printing, and has several constraints. Among those, the biggest is the enormous amount of particles to be moved back and forth in our process, and the cons and the pros is that you can create any kind of shape without any constraint except the strength of the material. because
is it like the powder bed printing?
yes, the academic environment recalled my invention in the way they like, that is particle 3D printing. At the beginning, to be honest, I call it the stereolithography because stereo means three-dimensionally, lithos means stone, and graphic means printing stone in 3D. But the academic environment has insoluble, infinite ways to redigest.
Let's agree to call it Enrico printing from this webinar onwards. Let's rename it once more. Enrico, we have been talking about sustainability just before you joined. I would like to hear your thoughts in 1 or 2 minutes about what makes D-Shape contribute to sustainability in construction in terms of waste reduction and decarbonization.
Well, at the beginning, I was completely mad about the environmentally friendliness of D-Shape because it was born to be, let's say, first of all, on-site, in situ resource utilization based. So the driver was to go and shape sand in 3D using a machine. First of all, should be sustainable and low carbon footprint, because if you want to build a house, let's say 100 square meters per floor on 2 floors, you need to move people back and forth from the building site to home for, let's say, 3, maybe 4 months, and spreading gasoline back and forth just for the logistic, just to move the people, not to mention about the logistic of the equipment and the energy consumption. So the idea to print a push button and realize digitally, let's say, a building structure in, say, 1 or 2 weeks in one go is a dramatic drop of energy. The third matter was in terms of sustainability, in terms of human being, by the human being side rather than the environment. Because as I used to love to say, living in a beautiful place is good for the soul and enhances self-improvement. So the main driver of this project has been sustainability in terms of also ethical aims, because living in a home is nice, but living in a beautiful home is even nicer, and is a driver of self-improvement itself. So about the advantages of digital manufacturing is that if in principle everything goes smooth, and Eric knows very well what I mean, everything goes smooth, you can have a very precise time of delivery. You have zero waste in terms of materials, and again, all that complex in using environmentally friendly binder. That's why at the beginning I wanted to use not Portland cement, but magnesium cement. Unfortunately, I was frustrated in my attempts, because at the end of all, the ruler become the main constraint. Regulation don't allow you to make these fantastic new materials. Now, I'm really corrupted, let's say, because I want to stay on business. I had to use Portland cement to print my stuff, and I'm now truly investigating and working on a new material that I heard about 15 years ago, but I didn't care at all, the tar geopolymers. That is a promising field of new materials, despite there are pros and cons about the real environmentally friendliness of this new material. But the mechanical properties are so fantastic. Maybe Henrik has made something with geopolymers that there is no match in terms of strength of the material. and thermal properties and for fire.
Is a field of its own, and I think if we go down that tangent, I think we'll never come out of it. I would like to go in another direction and talk about another driver really that is pushing the construction market right now, and that is urbanization. I have an estimate here from the United Nations that predicts that 68% of the world's population will be living in cities by 2050. That is 2.5 billion people moving to urban areas. To put that into a better perspective, that is an average of 200,000 people every day trying to move into cities. This will lead to a very obvious, or maybe not so obvious, problem of space constraint. I mean, eventually we're going to have to ask the question, how high can we go? Now, I know, Henrik, you mentioned that your printer can go up to 8 meters, 3 stories. Do you think that's going to change in the future? Do you think that's the limit?
No, we are changing that already next year. I cannot reveal the details, but we have already made a printer that is way taller. That's coming next year.
Do you think that the gantry printer has an inherent disadvantage compared to prefab or the robotic arm in terms of the printer having to be bigger than the house it has to print?
No, quite on the contrary. I think it's an advantage because it means that we can move a tool around anywhere in that build box very fast. So if you start thinking about applying multiple tools on the building, instead of just thinking about extrusion of concrete, then obviously to be able to master the whole build box at the same time is a huge advantage. So no, quite on the contrary, I think it's one of the major advantages that will become clear by next year and the year after, when more tools will be available on the printer structure.
Enrico, what is the maximum size that can be printed with the D-shape? Do you think that you can go multi-story?
Derisory, I might say. The biggest printer I sold to a Spanish company called Acciona, with whom I supposed to partner, and they didn't at all. And it's in Dubai, and the printer is in Sharjah, I guess. Is a 6 by 3 meter printer by 3 meter deep. So it's a 36 cubic meter printer. So compared to other printers, is very small. Usually, willing to print on site a house with my technology, and I'm very doubtful that I ever succeed in this effort. I already gave up about that. The biggest printer I might do, being reasonably sure to be able to manage it, might range between 9 meters by 12, by 15, or 12 meter by 12 meter. Visually having millions of euros and being truly committed, we might make a gigantic machine, 24 meter side, but what never happened. I will die before to see this opera. And I have a comment about what you were mentioning about the urbanization and the growth and the trend of overpopulation in the cities. Well, I'm an inventor. I'm a visionary man. Because of habitude, I always tend to go in the opposite side of what common sense say. This is the foreword, so the preamble. Well, because of COVID, COVID has been something really disrupting, at least here in Italy, where I am. I think about that. Actually, I'm inside a real estate agency here. My wife works in the real estate, and what is strange to say is that there is a dramatic increasing of people that want to escape from cities rather than going there. So most of the business is going toward private villas, not in the nowhere, but quite far away, because people work in distance today. So if I'd be you, I would keep an eye also about the possibility to make infrastructure intervention to spread the cities in area of the country that are actually in the nowhere. Because it's even better for the soul to live in not overlap with each other in multi-story buildings. This is my opinion.
I want to move on to another point here. I saw a lot of very interesting details in Henrik's presentation, but I want to ask the question before I get to Henrik. I want to ask the question to Yannick. Considering you have new operators of the machine, they've never worked with 3D concrete printing before, how quickly can you get them to be proficient with the machine? And basically, I want to know, what's the learning curve like?
It depends on how smart they are.
No, Yannick took very long.
Yeah, I need a
very
long
funny story to say about that. Yeah. I remember.
I can bring maybe one project in perspective, right? So the 3-story house, the biggest one in Europe, was built by myself and 2 students. And the students actually started 2 months ago. So when you have craftsmen or engineers which are done or whatnot, I think with the machinery you can start after 1 to 2 months. Then they know the most things. But you still need one person who's experienced in construction. So you need one person who has experience, but the rest will come to the other 2 guys, and you don't need more. So 2 people, 3 people using one printer is enough.
Yeah, I mean, when I was the statistics, I was looking at the data from Henrik's presentation. When he talked about the bod, which he first built in 2 months, and then 2 years later, he built it in 28 hours. I mean, that's a big jump. I also noticed that the printer is different. Was that due to any technological advancement, or was that due to the operator skills?
No. It's clear that there were more factors at play here. It was a different print material. It was a different pump, and it was a different printer. So it was not only a learning curve effect, but actually, if you analyze that project also, you'll see that actually we printed 3 days of approximately 9.5 hours every day. On the last day, where we printed 9.5 hours, we did 55% of the building. So even during the project, we increased productivity a lot. So if we had the productivity at the end, if we had that from the beginning, we probably would have been done in 13 hours or something. So that's why we're saying if we had to do it again, probably would be down to 10 hours. And those are the learning curves. And I mean, it's very similar. Think about when you learned how to drive a car. The first time you were fumbling around. I had an American telling me, yes, I drove into a light post the first time, right? So that's just how it is. And I mean, we also made many mistakes with the printers the first time. But, then you get the hang of it. In terms of how easy it is, we generally, we give training to our customers. Most customers prefer just to have 1 week of training, and then they get by themselves. I'm actually on my way down to the Middle East, to Oman next week, because there we trained them for 1 week, and then they printed themselves, and now they finished the building and so on. So it is not that complex. It doesn't mean that they, but Haida, it doesn't mean that they master it. It means that they know how to do it, but they don't master it yet, right? They know what to do, but they are not perfect at doing it.
But they still need guidance from Cobod to deliver an actual project.
Once in a while, they'll get the guidance. We'll get on a video call with them or something. They run into special issues. How do we do this? How do we solve this? And so on. But in essence, they can get by themselves after a week. It doesn't mean that they are mastering it. It doesn't mean that they're perfect. We are not even we are perfect. We are still learning as we go. And even I would say, Yannick, you would say the same thing, right? That you're still learning from project to project. Even after
I'm almost perfect, but yeah.
Let me go
but it took a long time.
It took a long time. Yeah.
Go to Roma. me talk about some other type of learning curve. I mean, I saw in your presentation you had really interesting items. You had some weaving going on. You had some double curvature going on. Tell us about the digital, well, let's say the design part. You know, do you think that is an easy learning curve? Do you think architects and engineers in the industry today already have that knowledge? Or do you think that's got a steep learning curve?
Well, when we equip a partner with a machine, we deliver also a training for operating the machine, and most of it we recruit, and the partner recruit from people from masonry, and another training 1 week each for the design. But the design, yes, it's better if we start with somebody that is already an architect or an engineer, and that is already able to say at least 3D model something, not necessarily with code, but at least with 3D modeling. Once you have this, it's not that difficult. And basically, our policy is to keep all the unpredictable and difficult thing for ourselves, and to deliver to the partners only things that are basically able to be used as they are, without too many difficulties. That being said, I think there is much to learn for everybody for design with this kind of technologies, and we are partnering with a lot of academia, teaching included, especially in France, a little bit abroad, but especially in France, to be honest. And we are working with schools, right, to try and shift progressively the concerns toward those things actually. And all our teams, basically almost all our funding teams, were coming from the pioneering master degree in France, who was the first to study robots and algorithm for architectural design. And today it was weird at the time, but today almost all the major schools have something like this in France. So it evolves, definitely.
Yeah, Roman, let's jump to another topic I wanted to ask you, which is the two-component material that you're using. My question is, using the two-component should theoretically lead to less blockages with the machine. What's the downtime with your machine? When you want to print something, how often do you get blockages?
What do you mean blockages?
Any sort of problems with the machine when you start printing, any sort of problems that force you to stop printing? Maybe concrete hardening in places where you don't want it to, pumps jamming, things like that. How robust is your technology?
Well, it's very robust when we do things that are, let's say, that we know we do. So basically, when we limit ourselves to a certain kind of material, a certain flow rate, certain geometries that we have de-risked before. So today, for example, the table that you saw, we know that every geometry possible is printable, and we receive it, and we have, let's say, I would say maybe something like 2% of the table that leads to an error that makes them not okay. I would say something like that. But in the same time, we are always developing projects to push, the technologies. For example, today we are now able to print real concrete with aggregate at 8 liters per minute. And here, what we are experimenting, of course, we are experimenting more, machinery problems because we are pushing the design. But we keep that to ourselves, and we try to give our partners only things that are, without problems. But of course, I mean, a problem can appear. It's rare. But of course, it can appear.
Yeah, let me go real quick on this topic to Yannick. Yannick, on your projects, how many blockages have you had where you had to stop printing?
Overall, 5 projects.
Generally on your projects, give me any example. Real quick, please.
In total, 3. But it
blockages on one project.
But never in the printer. It was always in the host system. So I mean, we had in 5 different projects, I had 3 different materials. And every material delivers another risk of blockages. When you have bigger aggregates, you have a bigger blockage risk. When you have more hardness in the material mix, you have a bigger blockage risk. When you have 35 degrees, 40 degrees outside temperature, you have a bigger blockage risk. So it depends. But in total, I had 3 blockages which were not, which we didn't want it to have. So we had to replace the whole hose. But that's something, when you know the material, the behavior of the material, it's something what is not, which is not coming up. It was still in our learning process. Yeah, one was, for example, in the winter season in the Bavarian project. It was just, okay, it was too cold. That's it.
Okay. Let me get to the final point of today's discussion, which is costs and business. And I'll go to Henrik on this one. Henrik, considering the high cost of labor in Europe, is 3D printing cheaper than traditional construction currently?
Yes.
It is. And does that factor in the cost of maintenance and all of that?
I will answer a little more qualified. One-offs are never cheaper if you only do one. If you do scale projects like 20 or 30 buildings, and you know that you know the technology, this is meaning it's not your first time you use it, then you will be able to save money. Yes.
Let me put it in another way, Henrik. The projects that you delivered in Europe, were they cheaper than traditional construction?
We didn't deliver other than the very first building, right? We don't deliver projects.
When you're working with your partners, your partners, I mean, you're selling the technology, I'm sure you have data sharing back and forth.
Most of them probably not, because again, these were first projects for them, or maybe first 3 floor. Anything you do for the first time, you'll never be an expert at, also cost-wise.
Okay, considering the low labor cost in the UAE,
yeah,
and the GCC region, how long do you think it will take before it becomes profitable here in this region?
I think it'll last a little bit longer, but you have one advantage in terms of buildings is that the concrete material is actually very cheap in UAE. This other construction materials, so there's an even better reason for using concrete in UAE than in other places. I think speed is also of essence, and I think overall there's a political interest in upgrading the workforce and maybe not having so many immigrant workers anymore. So I think that all plays well into the hands of our technology.
Second to last question, Enrico, can you tell us about, do you have any cost numbers regarding your technology? Have you done any studies? Do you know how it compares to the other 3D printing technologies? You're on mute, Enrico.
You're still muted, Enrico.
Sure, of course I have.
Real quick, please.
I wasn't prepared to this question, but if you give me a while, I will share my screen and I will search from.
No, Enrico, I cannot do that, but in 2 minutes, just brief this, best to your knowledge.
At a glance, I might tell you that if some sheikh over there, Al-Nabuda, Luta, and I remember all the list of the name who received and saw my presentation, who'd ever accepted to invest $1.7 million to purchase a 3D printer, including not the first building, but at least the 3 buildings, otherwise won't work.
Thank you, Enrico.
I might have delivered 1 2-story building at 30,000 euros, 200 square meters at $30,000. Make your calculation.
Thank you, Enrico. I would like to, last question, where I think I will address Romain. Can you tell us about how you work with your partners to make sure they're profitable?
Well, we make a business plan. and we try to see what project they can have, and basically they can also specialize in an area on another area. As you can see, we go from furniture to bridges, so not all of our partners do everything. So it's a question of market and of abilities. I think most of what we do, most of the project we do are always profitable, because we wouldn't do them if they were not. Only, as Enrique was saying, the first very ambitious project, of course, are none, but we make them ourselves, and not for our partners as much as we can. So that's my answer.
Thank you, Roma. I have a lot of questions from the audience. I do apologize to all our audience that I wasn't able to convey their questions. I will try to put them in an email to our speakers to see if they can answer them.
Yes.
Thank you very much to all of our panelists today. Thank you, Yannick. Thank you, Henrik. Thank you, Enrico. Thank you, Rama.
Thank you.
It has been an absolute pleasure talking to you guys. And thank you very much to our sponsor, Sharjah Research Technology Innovation Park, for having this webinar. And a very, very big thank you to everyone in the audience. Thank you, everyone.
Thank you, everyone.
Thank you.
Thanks for the invite.
Ciao, Eli.
See you.
Bye bye.
Goodbye.